Sorry, trying to my window here. I lost you on my 100 screens I got open. What the hell?
You should see a little red circle on the tab with a Google Meet tab. It'll show you which one I'm live on.
Okay. What the hell did I do? I'm about to unplug all these monitors I got because I've done something to... Oh, wait, hold on. There you go. Not using Google. I was using something else. All right. Ready.
Okay. All right, cool. We were just getting into it, right? So just got to meet the team here. So I'm going to just jump right into it so we could get into the meat of this here quickly. As far as our organization, we're U.S.-based, founded in 2012. We're right by Levi Stadium in San Jose, California. We're the leading provider of 3D LiDAR solutions and perception software. I'll talk about that in a bit for physical security and smart spaces. Base level, how this all works, we're a manufacturer of these sensors. You can see it's about the size of my coffee mug right here. We also develop software that interfaces with them. But in essence, it's a PoE Plus device. Connects just like your standard IP camera. Once it gets powered up, it starts spinning really fast and shoots lasers in a 360-degree motion. We use time of flight as a unit of measurement, so we can measure speed of light. Light is constant. So every time a laser hits an object, it leaves a point in the sky and bounces back to the sensor about 1.3 million times per second. The easiest way to understand what we do is we don't see like cameras do, but if you ever see my favorite movie, remember when Neo sees Detective Agent Smith for the first time, the ones and zeros are dropping from the sky. That's how we see. So we don't see like the camera does. Like you can't tell that I've got headphones or a blue hoodie on. You just won't be able to see like that. Our solution sees everything in 3D silhouettes. Not only do we manufacture the hardware, but we also develop the software. So the software, which is a fancy word they call in the 3D LiDAR world, is perception, is just like a IVA, like an intelligent video analytic. The perception is telling us, is it a person? Is it a vehicle? Is it an unclassified object? Is it going this direction, that direction? In depth, volume, down to centimeter level accuracy. Then from there, we pass it directly to several of our partners. We have a ton of integrations from VMSs, cameras, PSIMs, business intelligence, smart city, the list goes on and on. We have quite a bit of it. Now, as far as the sensor goes, you all know what a camera is. Bottom right corner, mounted to our vehicle, driving downtown San Francisco. The image is limited to the optics. It can only see in a two-dimensional space. It can't see to the sides, the top, to the bottom, or behind the sensor. You can only see what the image is providing as far as intelligence goes. But with our solution, if I wanted to, I could pause this screen right here. And if I want to, I could jump on a building 3 blocks down the street, then virtually turn the image around. I could wave to myself as I'm driving towards the building that I'm standing on. Just so you have a frame of context of what I mean by that. This is my home office. It's a bird's eye view. You can see I'm the yellow box. I'm doing some jumping jacks right there, so you can see it's all in real time. And behind me are the sensors. So as I mentioned earlier, typically this is what a camera would be seeing, looking at me from the back. But I could flip this around. Now I'm looking at myself, looking at my screen, but the sensors are behind me. This is the power of 3D, is that I'm able to give you the capability to see from all kinds of dimensions in this space. But as it pertains to intrusion, alarm detection, event detection from like PIDs or counting or tracking, we could create 3D detection zones, such as a case, my first detection zone. I've created this first knock. This may be the exterior barrier. I know we're talking corrections a little bit. We know correction facilities have 3 barriers: your exterior gate, barbed wire, interior gate. So you may have multiple knocks. Your first knock, sound an alarm. Second knock, get the guys with the wooden bullet guns out. Third knock, bring the drones in, bring the artillery in, whatever, right? So what you could do is you could create that multi-knock scenario by creating additional walls. And you can stack any number of zones that you want to your heart's content in this environment. You can increase the height, you could decrease the height, you can stack them on top of each other. In fact, if I wanted to create a new one right by my door, I want to say, hey, I want to create an enter zone right here. I want to create an alarm. If someone enters that zone right there, send me another alarm or bring somebody out to notify this person you've intruded into the area. Once again, I can increase the height. If I got a larger wall, I don't want somebody scaling the fence or the wall. We could do all of that in 3D. So once again, I can spin this around. I can look at it from every vantage point. And that's the power of what we're able to do with our solution, is that we look beyond traditional sensors in that regard. As far as the architecture, is pretty straightforward. Our sensor connects to your network, and then from there we transmit to our perception software, which is Cortex. That's where we're doing the identifications. A person is a vehicle, unclassified object. We give you zoneless, objectless, stateless. Everything goes then directly to our partners, such as your Genetech, Milestones. We got a lot of different VMSs in that regard. Now,
does this require a GPU-based server?
Nope,
or is
we are CPU-based.
All handled at the edge?
Nope, we are CPU-based architecture. We don't require any expensive CUDA, any expensive GPUs, any of that stuff. You can do one sensor per core and a half of compute is what we scale this out. And then you can virtualize this as you add additional processing. You can add additional sensors and scale horizontally as you add more sensors to your network. As far as compliancy goes, we're NDA compliant, number one, and very important in security. We're Buy America Act compliant. We're Trade Agreement Act compliant, GDPR compliant if you go beyond the U.S. borders, and zero PII risk. The sensor does 140 meters in diameter of continuous detection, tracking, and classification. It's PoE plus IP69K, and we do 100,000 hours of mean time before failures. It's quite a few years. A single sensor, once again, can track over 3 American U.S. football fields in width. As you can see, we're able to track from one side to the other with no issues. The software is 95% people counting accuracy, 98% detection accuracy of objects. It comes in Windows, it comes in Linux, once again, centimeter level accuracy, and we can track 1,000 plus objects in the software. So now let's get into the fun stuff. So we operate in very challenging environments, and I like to poke at the old holy grail AI, right? Everybody's claiming AI this, AI that. AI is going to solve every problem in the world, right? Unfortunate issue is AI in security hasn't really been the same as it is in other markets. Large language models or any sort of the generative AI, which is really cool. But in our space, it's still bound to a two-dimensional sensor. So when you're trying to extrapolate value, the biggest issue is that it doesn't give you depth to understand what's truly there. So like a traditional pixel movement or object detection algorithm that's doing some sort of AI is already failing here. You can see grandma and grandpa is telling me is one person. These two people at the kiosk is telling me is one person. So when you need accuracy for security, liability, or business intelligence, AI doesn't really take you all the way there. Say for security, for PTZ tracking, we'll do bounding box around the person. We're tracking this individual as he's going to the vehicle. But then when he goes behind the vehicle, because we don't get depth, we don't see 360, the camera scratches his head and goes home, missing the guy breaking through the window. Same thing with a vehicle. If the bounding box can't keep up with this fast-moving car, say we're in the Carolinas, he breaks through the fence, has a shotgun, boom, blows up a transformer. We missed the license plate, what the guy looked like, everything, but not with us. So what you see right here, this is our perception software. On the left, it's going to slide over in a bit. And on the right is a FLIR thermal PTZ camera. We don't do the camera, we do what's on the left. It's a bird's eye view, top-down view. This guy with his hands in his pockets breached zone number 1. This is him circled right here. And what you're going to see here is we're going to continuously send location data directly to the camera to keep tracking Mr. Bad Guy, Good Guy in the scene. Now, unlike the previous video you saw with the issues with PTZ tracking, when you have overlapping objects, we don't have that issue. As you see right about here, this is where PTZ cameras get confused. Do I track the guy in the foreground, background? I don't know, right? Now with us, there could be one person, 10 people, or 1,000 people in the scene, and we're still sending location data directly to the camera to keep tracking that guy until the guy moves a joystick, pushes another preset, or whatever your rules engine is within your VMS. Same thing with orchestration. Now, I think of orchestration as how we can better facilitate alarm management or operation within a GSOC, a security operations center, whatever it may be that you're applying this to. What you see here is our building at our HQ in San Jose. We have a PTZ camera on the north side, we have a PTZ camera on the south side, and we have two 3D zones you can see right here. Our LiDARs are right next to each other, just so you see what's going to happen right now. We have a bad guy that's going to walk into the first event zone, but the camera's sleeping. It has no clue what's going on. We immediately then salute cue the camera and start tracking the bad guy in the scene. We take over the camera. We're telling the camera that someone came into this event zone, tracked that person. We don't know what he's doing. It seems like anomalous behavior, some sort of nefarious. He looks like he's stealing the bag. So he jumps from event zone 1 back to event zone 2. The first camera goes home. Second camera then takes over and starts tracking him in the scene. We're able to provide that handout from one sensor to the next, all throughout, tracking all throughout the property. So instead of having a guy tricking around on the PTZ, hitting presets, moving joysticks, we take over all of that control. We operate in all kinds of bad environments. As you can see, it's raining cats and dogs. I'll zoom into the rain right there. You can see it's coming down pretty bad. Unlike a camera where you get a raindrop on it and it splashes, your AI is going to get all kinds of bounding boxes jumping all over the place. But with us, we're only tracking him and him only in this scene. We can do this in the snow as well. Once we've tuned to the environment, you see the snow falling down, but we're only tracking this bad guy coming up to the door. In darkness, does not matter. We create our own light. We're shooting lasers. So this office can be pitch dark, and we'll still count the ins, the outs. We'll create a complete digital twin of the environment, give you where all the walls, all the objects are, and we'll still do it at 98% accuracy as far as counting, 98% as far as detection. Now, I really like this use case because this really tells a story as to why we stand apart from every other IoT security sensor in the market. We are working with one of the biggest shipping and logistics companies in the world, and every year, either Google or Apple's coming out with a smaller, thinner phone that you can put about 30 of these in a box, 40, 50 grand a piece, and organized retail crime groups are working with these temp agencies and throwing these boxes over the fence. They're in their smoke break, right? So they asked us, how small of an object can you detect? So we took the challenge. Guys at the top ladder, golf ball, detection zones at the bottom, boom, we detect that. Drops a pen from top ladder, detection zones right here, boom, we detect that. Shampoo bottle happens at resorts. I don't know why these drunk people do it, but they drop them, boom, we detect that. Last but not least, water bottle, super easy, we detect that, not a problem. Now, I get asked all the time about blockages, signs, pillars, trees, buildings, walls, whatever it may be. Cool thing about our solution is that you can fuse multiple sensors together to create like a mesh network, if you will, where they basically overlap with one another, and you can create a massive digital twin of the space. So what you're seeing here is, if you've ever been to the Aria in Las Vegas, this is the MGM Aria property. You can see it's like a horseshoe or like a rainbow. You get dropped off by Uber here. You check in right here. Go and spend some of that hard-earned cash at the tables. Or if you're like me, you can go straight to Javier's and get some of that mole and enchiladas, best Mexican food in town. The important thing here is to understand that we only have 10 sensors here. They have 1,000 plus cameras on this floor alone, but we only have 10 sensors. You can tell by the red, green, red, green, red, green. These are the XYZs. When I click play, you'll see that we'll be able to spin this around. We can track every footstep a person's taking. We'll see on both sides the slot machines, walls, aisles, blockages, scenes, whatever. We see everything in this space. Once again, as long as you have a laser overlapping with another laser, it continues the world as if it was one complete cycle. So we can track when a person gets dropped off, checks in, gambles, goes to the hotel room, goes up the elevator, whatever. As long as we have LiDAR placed, we can track every footstep in that environment. We do this in pretty crowded environments too. This happens to be the Louvre in Paris, France. And they were tracking like priceless artifacts like the Mona Lisa or Van Gogh. You can see they have a few detection zones right here, the zones right here. We're tracking every single object in the scene. There was about 700 people at this event, so we're tracking every single footstep. So if someone reached the Mona Lisa square zone, we would then trigger the access camera, then start tracking inside of that audience seamlessly without having to have a guy trigger around and follow along with a preset or a joystick, which was, pretty difficult to do. Now, we have a ton of use cases. I'm not going to go into every single one. I'm just going to try to stay focused on security for you guys. But we do perimeter intrusion, bread and butter. Mobile security towers, we do quite a few of those around the world. Server rack security, we have a 2D sensor where you can flip it sideways, and we create a virtual curtain going horizontal or vertically, depending if you want to put it on a roof or across an aisle of data racks. We can do man traps or vehicle traps, so we can sense when a person comes in, when it's a one in, one out only type of scenario. We can do real-time locating systems where we bound to access control video and LiDAR to track a person going throughout a hospital, a data center corridor, a research and development facility, the list goes on and on. Smart spaces, we do quite a bit in retail, casinos for business intelligence understanding, consumer journey, path, intent, occupancy, queue lines. We do a lot of cool stuff there. Man overboard, I've seen applied a lot into commercial real estate, into tech companies trying to catch a potential suicides, people jumping over. But we're also doing this on petroleum platforms and cruise lines. God forbid a cruiser falls over the side of the boat. We could track that and notify the conductor to slow down so we can throw some lifesavers out in the ocean. The other ones are pretty self-explanatory. Rooftop security. We do grail, tunnel intrusion, safety at tops over at stations as well, speed violations, smart city. Now, these are our primary markets. We have 22 international airports. We just announced Vancouver Airport not too long ago, where we're doing multiple terminals with them. We do quite a bit of smart city, retail. Critical infra, I said, is our bread and butter, from corrections, data centers, ports, substations, the list goes on and on. Commercial buildings, we can tie into utilities such as lighting or HVAC and turn those off. If nobody's in the room, turn them off. That's what Facebook Meta did at several of their buildings, where they know a lot of people were working remotely. There's no sense in having the AC on the second and third floor when nobody's there. So these are primary use cases by markets in critical infra for data centers, energy, water, substations, corrections. We deal with perimeter intrusion, man traps, mobile surveillance, RTLS, cabinet rack security. But I really like to showcase this case study because this is the aha moment. We're working on one of the biggest global data centers in the world. I'm sure everyone on this line shops with them at some point or another. That's as far as I can go and say who it is. They say at any given time, they were telling us that in a 33-week period, they tested at one site. Their best site was generating 178,000 false alarms, nuisance alarms, all kinds of alarms. Only 2 of those, needle in the haystack by definition, 2 of those were real alarms, right? So they knew they had a massive problem because you got that one disgruntled ex-employee who got fired for smoking. He goes on darknet and he's able to pick up the latest, greatest malware. He's going to put on this USB drive, and he knows how to sneak in because he knows where the smoker's corner is. So they knew they had a problem at hand, right? So after testing well over 2 years, they tested everything under the sun. AI, radar, microwave, RF, fence shaking tech, everything under the sun. They finally landed on us with 50 sensors on one side of our solution and their best layered approach. It was like a Frankenstein solution. Same time period of testing from one to the other, their best site generated 22,000 alarms. Ours generated 5 actual alarms. We would have saved them 3,600 hours in pointless forensic work, pointless investigative work. So think of this 3,600 hours and how they could spend it towards you guys, buying more tech from you, buying more professional services, buying more whatever it is that you guys could potentially upsell, instead of them losing it on operational expenses that was going nowhere, right? I did mention about real-time locating systems that we can do. So this is an RTLS solution for a data center. It could be a hospital, it could be a research development facility, it could be a government, federal gov space. We don't know who track 42 is, but we know there's a door reader there. He's going to present his card, he's going to badge in, and track 42 turns from John Doe to John Smith. We got camera, we have LiDAR, and access control, all tracking on the property. We do quite a bit in smart cities as well. We do traffic flow, vehicle detection, public transportation, crowd flow. We do a lot. You can see our sensors all throughout intersections. You go to all major airports in the U.S., you'll see our sensors mounted up on walls, and we're tracking people coming in and out. This was a smart city deployment. In fact, you can look this up on Google. In Florida drawbridge and LiDAR, you'll see our solutions deployed across several bridges. And the issue here, they have physical tenders inside these cubicles that are big, or these boxes, and they raise these bridges up and down, and sometimes they fall asleep because they're too busy watching TikTok or Instagram. Vehicles fall into the water. People die because they're already halfway up the bridge and they fall over, and so on and so forth. So our LiDAR is now tracking when people get too close, and it's not allowing to raise the bridge in those scenarios, right? I'm not going to go too much into airports, but we do quite a bit of airports. You see our sensors deployed here. I mentioned Vancouver Airport. We do a lot of ITS as well from transportation. We're doing analytics, crowd flow, security, the list goes on and on. Now, I do want to hone in on the perimeter intrusion detection, tying it into corrections, because I think that's how we originally started talking. From critical infra, perimeter intrusion, we're able to see pretty large, wide, and we're able to see in 3D, right? So this is Saudi Aramco, one of our bigger oil and gas customers in the Middle East. This is a top-down bird's eye view through Google Maps. You can see the oil tank, a row of cars here. This is 4 sensors. You can tell the halos right here, 1, 2, 3, and 4. Now, the cool thing about our solution is we can eliminate noise and make it super granular so that you can get rid of nuisance alarms, such as the case right here. I don't care beyond 2 to 3 meters on this fence line. I only care about the fence line right here. So all this area that's going to create noise is eliminated. And now we're only tracking the 4 people, 1, 4, 2, and 10. But we track them continuously from one sensor to the next, without even losing track of them all throughout that journey. The other cool thing about our solution is that you can stick our sensors inside of a substation. So unlike RF or, let's say, radar or other technologies, you're not going to be able to stick those sensors in areas where there's a lot of metal, EMI, so on and so forth. But with us, because we're a light wave, you can stick our sensor inside of a substation. We can track inside the substation and not have any interference or any of the issues that you typically would with other solutions. Now, I did mention corrections. We have about 9 prisons in Korea right now. We haven't done any in the U.S., but the use cases are exactly the same, the applicability. So as you can see right here, we're tracking people going up and down the fence line right here. If anyone touches the wall, then it will obviously initiate whatever event to action workflow would trigger within said third-party VMS. We got a lot of applications there. We do borders as well. So in Laredo, Texas and Mexico, we're tracking potential drug importation, and then also any illegal activity that may be going on at the borders as it pertains to that.
About how many feet?
I'll highlight some TCO. I'll go into some of the VMS stuff and camera stuff, and then I'll open up for some Q&A.
Perfect. One question I do got about on a fence line perimeter. About how many feet coverage does one sensor capable of?
Yeah, so a single sensor is going to give you 140 meters in diameter. If you only have one sensor, you're going to be able to see about 3 football fields, U.S. American football fields, wide in coverage from edge to edge. There is a blind spot directly below the sensor. We're not shooting lasers down.
Right.
So you're going to get a donut. So as long as it's about 3.5 to 4 meters up, your donut below should only be about 8 feet wide, if at most, right? But if you have anybody that's underneath the sensor, then your security solution's already failed, right? Because we should be catching them at the perimeter of the laser sensor, unless someone's digging in below, which I don't know. I haven't heard of any too many chopos here in the U.S. lately.
Yeah.
So yeah, we'll get quite a bit of coverage. We typically overlap them at the 50 to 60 meter line, depending on the dynamics of the environment. Is it hilly? Is there a lot of foliage? Is there obstructions? But that would really come down to a site assessment, really understanding what kind of environment we're working with. If it's flat, pretty straightforward. If it's a square, put one at each corner. It's pretty straightforward depending on how big the environment is we're trying to cover. Such as a case like this, I'm sure you'll find this interesting. This data center was going to do trenching, conduit poles. These poles are about 40, 50 grand a piece. This isn't cheap, right? So we saw an opportunity to take it to the inner circle where there was power, there was infrastructure. So what we did, we came in with 8 LiDARs and 4 high-end PTZs, giving them better optics and giving them more accuracy coverage around the halo of the property. So much more elegant, less infrastructure, less spend. Ultimately, it was the direction they decided to go. As far as man traps go, I mentioned this a little bit ago. We could do vehicle traps and man traps. This is into a data center. You see our sensors on the wall, guy badges in. Sliding doors will close behind him because the solution says it's only one person allowed. Once it closes, it then opens up the data center, allow him in. When he closes the door, the sensor sees nobody's in there, so now opens up the sliding door, allows the next person in. Vice versa, when he badges out, the sensor sees nobody's in that area. There's a zone in there, and he detects nobody's in there, so it closes the sliding door, and then it opens up the interior doors to allow him into that environment to then safely exit out the sliding doors. That's our man trap vehicle trap solution. Now, I did mention we can also do 2D virtual walls. So you've seen our flagship 3D sensor, but we have a similar sensor that has one laser that's basically shooting around horizontal like that. You can tilt the sensor like this, or you can tilt it like this. So if you're on a ceiling, you put it like this, and it's create a massive wall horizontally. Or if you put it like this, you create one virtual curtain going up and down cabinets in the data center, or maybe the facade building, or maybe around the correctional facility, wherever it may be. So as you can see right here, this one's flipped on its side, and what we're simulating is our guy walking up and down an area of cabinets, which is basically where your server racks are. We could create 128 unique zones where a person has to push or punch through, which is then alarm within the system. So it's another food for thought application for you guys to take into account. I did mention mobile surveillance towers. We have quite a few partners. Mobile Pro is one of them. We work with Compass Security. Securitas makes mobile towers. There's all kinds of mobile towers in the U.S. These are really popular as of lately. But you see how they mount it to the mast, and we're able to slow to cue the camera and track. And then one of our latest partners, PowerStack, does these really cool poles where they're solar powered, and you can put our sensor on top. We power directly through the sun, and we're able to do the tracking and all that information directly to the pole, provide information directly back to the head end. Now, I don't know, do you guys dabble in business intelligence analytics? Because if you don't, I don't want to waste your time talking about that.
No, I mean, we dabble a little bit of everything, so.
Okay, now I'll go over this briefly. So, prior life, I was selling analytics to retailers. They were trying to understand why they were getting drop in phone sales, tablets, and all that. So, two integrators came in with camera, cable, labor, installation, orchestration, server, about a week or so of installation, right? But the issue here, this camera goes offline, this camera goes offline. This system is useless because you don't know which way they came in, right? It's pretty pointless at that point. We came in with 2 LiDARs on each side of the store, 2 runs of cable, half a day installation, and then the end result was something beautiful. So this is me walking through the store. I'm going to pause on what was important to this particular customer. Now, they want to understand intelligence at the product level, back of the store, middle of the store, front of the store. These 2 tables, they want to understand dwell time, journey, path, intent, occupancy, queue line as it pertains to the mobile point of sale, and then allow them to gain intelligence on how to better assess interaction at the store level to provide better conversion so they get higher sales in certain areas. So how to interact at that floor space so they understand intelligence at that level. Now, we work with other big retailers like Dick's Sporting Goods used to do like 101 sensors. Now they do 18 LiDAR sensors. So instead of, application like this is an abomination. Like, everyone claims AI this, AI that. This is Walmart. Whoever sold this project, bless their hearts, because this is insane to see what they did in the store. This is, I would be almost embarrassed to do this, right? But hey, everyone's claiming AI this, AI that. So you see what we can do with a handful of LiDAR sensors, right? But from there, we give you intelligence with any of our partners. So this is what we did at SoFi Stadium in California. We could track, total visits, linger rates. We could track queue lines. We could track draws, lingers inside the store. But not only that, we could give you conversions, right? So we could also tell you total traffic by day, total traffic by month, by location. We could give you previous trends to current trends. Like if it's a casino, we're giving you pots and pans this week. We're bringing in more senior crowd. We got Guns N' Roses next week, so we know we're bringing a different crowd, and we can see what types of actions bring in different crowds and which ones equate to more money. Even at the floor level, we can tell you, hey, Dick's Sporting Goods, we see that hoodies is sucking wind, so maybe we need to move hoodies next to the fitting room, so maybe we get people touching and converting better. But even more so, we could give you top of the funnel action. So we know 72,000 people visited the store, 14,000 visited women's tops, 8,900 lingered before giving us a 6.82 conversion at the point of sale, which is the final piece of the funnel. You got the whole top of the funnel dribbling down to your forecasted sales, and now you can understand how to predict sales at certain stores. So some of the cool tools that we're able to provide, and we do this for several retailers, from Meta to Dick's to, we work even with the postal office where they're tracking inside the facilities to see where people are going for theft and also to improve the experience at the stores. Now, I won't go too much into Smart City, but as I mentioned, we do quite a bit in Smart City. Road France, we got hundreds of these poles monitoring speed enforcement on the highways. You go to Vegas, Frisco, Florida, neighbor China, just to name a few. You'll see our sensors at intersections all throughout. A lot of that cool stuff. In fact, if you go to YouTube, you'll see these videos, Florida Drawbridge. You can see how our solution is basically tracking at these intersections to prevent deaths at any of these bridges. Now, as far as our solution goes in integration, there's several ways to integrate with us. First and foremost, we integrate with all major camera brands, from Avigilon to Axis. We work with all major brands to salute a Q, from Bosch, Teledyne FLIR, iPro, Panasonic, GeoVision, Hanwha. We just don't work with the 2 or 3 companies that obviously are always in the news, so we tend to stay away from those companies. As far as VMSs go, we work with major VMSs too. So we have a deep VMS, a Milestone Expertech integration. We have a deep Genetech integration as well. We have integrations with several VMSs. The list goes on from Mirasys to Edge 360 to Digiport, Network Optics, Hanwha Wave. The list goes on. And there's countless more we'll be announcing for ISC. It's several that are currently in development. In fact, I've got BVMS right here in my home lab, which I'm currently tying into Postman and trying to finish the integration this week. That's a little bit about us. I'll stop there and open up for some Q&A for you.
No, that's cool. I came in for corrections, but I started thinking, Aaron, the solution for Millennium Park, they want to do the people count for their events. Stroll on State, same thing, and Loves Park just asked me for the same thing for their festivals.
Yeah, I was looking at the trailer solutions.
Yeah,
Adding that to the trailer would be
that would be
no problem at all.
Daily Center.
POE. Yeah, the Daily Plaza would be a neat spot. But then for STE, doing the fence line,
Yes.
and it's 150 meters radius.
140 meters in diameter. We do 70 meters radius.
70 meters radius. So
70 meters from the center of the sensor out in any direction. So giving you a total of 140 meters from end to end.
okay. So if you had STE, which has got nearly 1,000 to 1,500 feet, depending on if you do that dogleg at the south side.
Yeah. It's about 1,700 feet, or 1,600 about from.
Okay.
Because we looked at it from doing thermals all the way down every 300 feet, I think is what the camera called for.
Mm-hmm. So if we provide you a scaled map, you could put some point cloud diagrams on there. We could decide how many we'd need. And then you say, let's say you had 1,000 feet of fence line. You put 5 radars or lidars on it. You could still do that as long as you have an optical field of view with a 4DX camera. You don't need 5 PTZs as long as they can see that area.
You hit that on the nail, brother. So look, we're here to augment existing camera deployments and ultimately potentially bring down sensor count, because we provide a lot of coverage, so we can take over a single camera and move it around to track. Instead of having you put 10, 20x cameras down, we bring down your cost exponentially, because you only have to strategically place cameras now so that you can track objects in the scene.
Okay. And then in one of your examples, take us to ARIA, how does the sensor, when it's looking at a point cloud, it's getting it from the south, another sensor is getting an angle from the north. Can they overlap and see each other's light wave, but without you being confused, obviously, right?
Absolutely. So in our sensor configuration tool, when you start adding sensors, what happens is it creates a point cloud. And then you can immediately see within the software when the environment is not aligned, because you understand the walls that you're looking at. So once you get into the system, you can snap them together so that they overlap with one another. So, and they're each uniquely identified by different color schemes and obviously whatever you name the camera and IP address. So you can identify location and then get very precise to overlap the sensors so that you're maximizing your exposure and understanding everything that's going on, such as the case with ARIA. We just basically snapped all the sensors together, then triangulated with them together. Now, the other cool thing too, Eric, is if you got a really dynamic environment with hills and all kinds of weird things, it does not matter. What you do is then you tilt the sensor certain areas so that it's shooting down. In other areas, you can leave it flat. In other areas, you can point it that way. As long as the lasers are overlapping in that environment, you can snap it all together, and it's going to look at the environment as if it were exactly the same if you were walking it.
Okay. And then, I guess, we know we can see in snow, rain, all that. Does the
sensor get blinded by direct sun, or is there any considerations to make for, the morning sunrise, the sunset? Is it any considerations for that?
We haven't had any issues with that. We have hundreds and hundreds of deployments for external. That's not an issue. Now, I will call out the only time that we see any sort of degradation in the laser beam is in heavy, dense fog. I'm talking about the kind of fog where you can't see beyond 10 feet in front of you, right? But if you got, fog that's going to come in strong in certain areas, what we do advise is to have overlap closer from one sensor to the next so that you don't have that degradation. But say, for instance, when we're putting this on a cruise line, you put about 5 or 6 on each side of a boat, and we're going to see everything, even in the weirdest weather out in the ocean. Let's say they're in the Bermuda Triangle, where we're going to still see on each side of the boat without a problem. God forbid they go into the triangle.
Yeah. All right. So it's the water vapor in the air that's a potential problem. Okay. I mean, my only other experiences is lidars, or that handheld one that we had for mapping interior spaces. Can you take this one and hook it up with Revit models and get it so it's with CAD or exact floor plans?
I mean, you could if you want to, but we don't develop that software that does that kind of stuff. We have partners that do mapping. They put these on drones, but that's not our business. Our core business is security and flow management. So unlike every other LiDAR, every Tom, Dick, and Harry LiDAR is chasing the holy grail of self-driving cars and robots and stuff like that. We're hyper-focused in this space, and we're only working in this space. Now, there's other technologies that can do great for mapping and being able to provide that kind of stuff, but we're not dialed into that. I will say another component to take into consideration, Aaron, is that all the other LiDARs in this space, because they're throwing out all kinds of beams and they're claiming, oh, we see everything down to, we can see every single thing. They're putting out tremendous amount of data, about 200, 250 megabits per second per sensor. So if you start to equate, you'll save on sensor count because you see a lot, but it's going to cost you your life to go and support that network bandwidth backhaul back to the head end. Not with us. Our sensors are tuned for the security market. Each sensor is doing only about 20 megabits per sensor to our software, but then from our software, it's only putting 1 kilobyte per second per object. So it's getting very granular as far as object we detect within the scene. That's how we stand apart with every other LiDAR in the space too. Everybody's hyper-focused on making all these cars drive by themselves, but we're focused on tracking objects for security and business intelligence related.
Okay. Send me 5 of them and I'll test them.
So here's what I can do, Aaron. It sounds like you guys are interested. I can introduce you to the commercial team at this point. I'm purely the dog and pony. I only do demonstrations of our solution. I can connect you with our commercial team if you'd like to understand POC, if you guys want to get official pricing beyond MSRPs and all that stuff, they can provide you all the commercial details from this point go forward if you'd like.
Yeah. Definite.
Okay.
Yeah, that's definitely.
I definitely would like to do this, to be able to, I mean, this is cool enough from what I'm seeing to do a side-by-side, our own side-by-side demo before our presentation in April with this versus the radar and just, right, see it in our environment. And we only need,
Best way to test it, right?
yeah,
Get a sensor in and then put it to the test.
We're doing a shootout with a radar in early April, and with the approximately same range, those are 150 meter radius. You're 150 feet radius. You're 150 meter, so 70 foot radius.
Okay. Okay. Do you know the brand that you guys are shooting out with?
But the one system we're testing is the Axis radar.
Yeah. Very familiar with it. Okay, cool. I'm going to be completely transparent with you guys. There's a place for every technology. Every technology has its pros. Every technology has its cons. So Axis is a great partner of ours too. But when it comes down to tracking accuracy, you kind of get what you pay for. Our solution is going to be much more expensive in that regard. So I know what Axis radars go for. Great company for camera side. I don't know if they're exactly a radar company. There may be better radars out there, like your Echoes or your Magos and stuff like that, or your Owls.
yeah,
They're definitely new into the market space.
Yeah.
But they're also 180 degrees. Well, you'll be 360.
Yep. You already know. I mean, I don't need to tell you. You obviously know the details.
Yeah.
Yeah. So, okay, cool. So I could do this. Ray, Aaron, Nate, I'll introduce you to our commercial team, and I'll do via email. What I can do is get the formalities out of the way, so at least speed up the process. I'll put a mutual non-disclosure into that email.
yeah,
Go through it, execute it once you guys are in agreement, and then depending on who it lands on the sales team. You guys are Chicago, right? Illinois? Where you guys at?
yep, Chicago.
Okay, super. So I'll push it to our central team, and then they'll immediately jump on to, they'll respond either later tomorrow morning or later afternoon. Maybe it's already closing time over there, but they may respond here today. If not, I'll get the formalities out of the way, get you that. I'll send a product brief. I'll put a video link as far as some of the stuff that we do, and that you can always go to our YouTube. We're always updating with new videos there, and then they'll get you the commercial side of it for testing, for pricing, how to procure the sensors, et cetera, et cetera.
Yep.
Do you sell through the channel, or is it direct?
We don't ever sell direct. We only sell through channel. We can sell to your favorite distributor, Annex or Wesco, or we can sell directly to you guys if you want to set up terms directly with us as well.
Yeah, that's fine. Yeah, we're doing a lot with Wesco right now, so.
Yep.
Perfect.
Yeah. Super. Well, Ray, thank you for putting this together for us. I appreciate the opportunity to present to you and your team today. I'll send an email here shortly, and look forward to seeing some good stuff from you guys in the near future.
All right, appreciate it. Yeah, good job. Good presentation.
Before I let you go, guys, are you going to be at ISC?
Last minute decision. We'll see. We got a lot happening, so we're trying to figure out if I can swing it even a day out there.
Well, let us know. We have a booth. We'll be deep over there. We're going to have some really cool new tech that we're going to be showing up. I'll send you our booth location and a free pass in my email signature as well. So if you want to go out there, you get a while here to come out there, I'll be there. So I'd love to meet you all face to face.
Okay, sounds good. Thanks, Gerald.
All right, guys, take it easy.
Have a great night. Yep, bye.